Okay, welcome everybody to this my talk about GraphQL and Groovy. Of course, first a little bit introduction. Let me introduce myself. My name is Mario Garcia, for those who don't know me. Well, you can find me in Twitter or at GitHub. Those are my accounts. I think, yeah, my Twitter account is on the bottom page. So if you want to say something, say hello, you can. Okay, so something about me. Well, I'm a proud member of the Groovy user group here in Madrid. So if you are here in Madrid or around the area, just come in and say hello. Ivan is always very supportive, especially with the beers. What else? Well, I'm currently working at Kaleidos. Kaleidos is a small company based in Madrid. Well, it's as small as this photo. This is Kaleidos. It's a small company, but a great family. I can tell you that. Yeah. Sorry, I don't have a spoiler alert. Oh, my God. What? Okay. Sorry about that. Okay, yeah. So, yeah. Oh, I forgot to. I didn't find my remote, so I have to take this one. Well, anyway, my introduction. Let me start, please. Okay. So. It's 3 o'clock. It's just start failing everything. But okay, let me tell you that you may be here because of you have heard that GraphQL is the next big thing. Maybe because you are fed up of doing REST APIs, or maybe because you didn't find anything better. But that's unlikely, I can tell you, because Grit is great. Okay, but whatever it is, I hope that you will enjoy my talk. Okay, so what I'm going to be talking about in the next 45 minutes, well, I will be giving a little introduction about GraphQL, what it is and what it's not. Then I will be talking a little bit deeper about how you can build GraphQL query. And that takes some time, especially for talking about the types and the query language. And then I will be showing you a couple of applications made with Java, Groovy, and some frameworks or toolkits from the Groovy world. And finally, I will be giving some conclusions about what we've been seeing through the talk. Okay. So first, I need to tell you something about GraphQL, what it is. Okay. So what is GraphQL? It's been a lot of noise out there about what GraphQL is. If it's a web framework, it's a new way of doing REST. Well, despite that you may think it is not, it's just a query language. Okay. So because it's a query language, and also a server runtime spec, it doesn't have to do much more with the application layer. It's just a query language. We'll see later on that we can mix it or combine it with application layer using HTTP. But for the time being, just keep in mind that it's a query language. Also a server-side runtime, just to know how to serve the response for those queries. And it uses a type system to define the graph of the data you want to expose, and also the queries, which are, by the way, types defined in the GraphQL schema. Okay, 3 basic definitions or hints about what is GraphQL, but what is more importantly is what is not GraphQL. Okay, as I mentioned before, GraphQL is not a web framework. Okay, it's just a specification. It has many implementations in many different languages. But it's not about the web, or it's not only about the web. So it's not about only HTTP, and definitely is not about REST. Okay, So keep in mind, because it's one of the pitfalls that you may face when you start developing a GraphQL application, is that you come with the knowledge of the REST APIs and you tend to force that everything should be REST-wise, okay? Why I'm stressing this part, why I'm highlighting this specific topic, because we want to improve our applications and we want to find better ways of developing APIs or serving data to the end users. So why we could want to do that? Well, first of all, we have to keep in mind that REST is not a single technology. It's also an architectural concept. So it has many technologies going on under the hood. And whereas GraphQL is just a query language, okay? So what are the main differences between both that you have to keep in mind when developing a new application? Well, a very important one is that REST is always focused on one URI, one resource. So you have a URI that is defining a resource, and you have operations over that resource. Whereas GraphQL, you can specify a URI when you're developing an HTTP-based GraphQL application. But in this particular case, one URI, which is normally GraphQL, can serve many different types of data, okay? And many operations over that data. What else? The application layer. As I mentioned before, you would normally see a GraphQL application running over an HTTP layer, but it's not only that. You can be using GraphQL to query the database just to, I don't know, to do a script that does something that needs to query data. You can use GraphQL. So it's not tied to any specific protocol. Who is front developer here? Oh, few. Okay, you can leave it now. No, I mean it's a more front end and friendlier approach, because normally the back end is the king. When developing a REST API, normally the front end developer comes and start complaining because I didn't expose this, or I forgot to expose that, and that ends being a bottleneck, no? You know. And then it's when you see the situation that you have this meeting and the front developer told you that he needed a bunch of fields. You implemented it, and he comes back and say, you know what? I forgot one field. And then it's what you look at the guy and say, no problem. I'll see what I can do. So trying to explain a little bit deeper what is going on with GraphQL, I will give you a challenge. The challenge is about a user that may have a requirement. This requirement is, I want to expose all James Bond films information. Okay, that could be a very legitimate use case. And the user is telling you, well, users will only use web browsers. Okay, okay, only web browsers. Okay, for now. Okay, but we have to be ready for mobile. Okay, at some point. Sure, why not? So what do? Well, we normally would build up one API endpoint just to serve the resource, the film resource, but only targeting one device. But because we have thought in advance, we may still create a couple of views for the same data in case the front end will come back and say, you know, it's too much information, or it's, well, that's not normally happens. It's the other way around. I still have need more data. So one API, one device, a couple of views. Well, then shit happens. And you not only have web browser, but you have many different devices that are asking for many different resources. Oh, not different resources, sorry. For the same resources, different type of views. I need less data. I need more data. Some devices have poor bandwidth, so they need to even ask for less data. You can try to mitigate this, but that normally gets worse, okay? And you can have this pretty normal situation when a user want for the user home, for example, to show different types of information. And normally is solved by the front-end developer by, for example, reusing views or aggregating calls. Still, it might not be enough, and the front-end developers will come back to you and start complaining and saying, I need more, and I need more, and I need more, and then, okay, I mean, I'll try to figure out what to do, okay? Then you remember the user when he start asking you to build up the application, when they were saying like only web browser. I think he meant in addition. For now was meaning within the next 2 weeks, but it's winter is coming. And of course at some point will mean probably the next week, okay? So it's a nightmare, and maybe GraphQL plus HTTP would help us just to improve that situation, okay? So what I'm going to show you is an example of a schema. Let's see, this work, okay? Yeah, so basically what we are building here is like a GraphQL server that its own responsibility is just to process the queries from the devices and do the underlying queries to the microservices that we may have under the hood. That is pretty good, because you still want your REST APIs or whatever the microservices are to keep with one single responsibility. And the GraphQL server, its only responsibility is just to process queries, okay? So that's much simpler, and you may end up that a commitment with the front-end developers that whatever is exposed, whatever data is exposed here, they will be able to unleash all the information, okay? So, yeah, what changed from the previous schema to this one? Well, the GraphQL HTTP point is proposed as an endpoint for a common query interface, okay? It's not like a monolithic application that has the knowledge of the data and also it processes the queries. Its only responsibility is to process the queries and get back the information. Therefore, it's a lot more flexibility for the front-end developers and for the business. And your REST, whether you're having microservices based on REST or not, but those microservices will be easier to maintain, okay? And of course, we have to keep trying to keep the single responsibility in each one of them. So, okay, very about what can GraphQL gives you in return, and let's see how can we execute a query. Okay. So we've seen what is GraphQL, and we want to execute queries just to see how it works. So in order to execute a query in GraphQL, you need first to define the types, which means the data you're going to expose, just to give it a structure. You have to define as well the queries, which, by the way, are also types defined within that schema. And finally, execute the queries against the schema and also against the underlying implementation. Okay, let's see an example. We were talking about James Bond. Well, here it comes. We're going to see all those steps all together. Okay, so first of all, the schema. Here we are defining what we are going to be exposing, which is the films, which, well, I kept to the minimum, so here I only have 2 fields. The title, which is defined as mandatory. That exclamation mark means it's mandatory. It's required to be included. And the year, which is an integer, okay? And here you can see that we are defining another type, which is the queries, where we are grouping all the queries that we are going to expose. We are only having 2 of them. last film, which is the last film, last James Bond film, and film a year, which is the film released by a given year. Okay. Once we have defined all the types, we group them into the schema field, and we define what are the group of queries, and we may define what are the groups of mutations. We will be talking a little bit later about them. Okay, this is the URL from the GraphQL specification. So in case you want to know more about the schema, you must go there. Okay, so let's see this a little bit closer. Okay, so as I mentioned, we have optional fields and mandatory fields. And while the client can add or omit as many optional fields as it wants, it must add all mandatory fields that have been defined in the schema. Okay. What about the queries? Well, queries can always use types or scalars. A type would be a user-defined type, and a scalar would be the basic types such as integers, strings, floats, and so on. And also, queries may have arguments. Okay, so in this particular case, we are passing the year just to get a film from that specific year. So what would be the first example? If we want to get the last James Bond film, I will be sending this query. So I'm sending the last film, and I'm only interested in the title. And the result, if we were running an HTTP implementation, I will be getting something like this. Under the data field, I will be getting what I have asked for. Okay, in this particular case, the last film is a Spectre. Okay. Let's see this a little bit closer. As I mentioned, the last film is the query I'm interested in, which is a field within the queries type, and then the title is the field that I'm interested in. Okay, what else? What happens if I forgot to add something, or I did something wrong with the syntax? Well, like this particular case, I'm not adding any mandatory field, so I should be getting a message error. Okay. Okay. Enough theory. Now I'm going to see with you a couple of examples with code. What JVM libraries are out there for us just to develop a GraphQL application? Well, there are some implementations from many other languages. In Groovy, there are at the moment, I would say, 1.5. I will tell you why in a moment. But the principal reference nowadays is the GraphQL Java implementation, okay? Because it's a very active community. They are following all the specs, and they try to be updated with the latest specification from GraphQL. So let's see an example. So how can we define a schema with GraphQL Java? This is Java code, okay? Sorry for that. Well, the film type, it has title and year, and we have to create a new object given a name and create the two different fields, which one of them is of type string and the other one is of type integer, okay? Okay, fine. Then the queries, the same way, because query is a type, we are creating a new object type, and then for every field will be a query, okay? Here we have the query last film, and this is very important. We have the data fetcher. The data fetcher is the function that is going to retrieve the data from that query. So every time you hit a GraphQL server asking for a specific query, you will be triggering a data fetcher, okay? Will we see more examples about that? As I was mentioning, the data fetcher is just a functional interface. So I can create a method reference in Java 8 or a closure in Groovy. method reference, closer for the win. Or you can use both. You were using Ruby with the parrot parser. Anyone is using or have checked out that the parrot parser? Yeah, the usual suspects. Okay, cool. We have to talk about it later. Okay, so we have the schema defined, so we want to execute the query. So yeah, let me check this. So basically, we are creating the GraphQL object, passing the schema, and then we want to execute the query. We may or may not include the context, which is helpful, especially for passing the application layer information, for example, for authorization or authentication. And finally, you may want to add variables. Okay, so here I'm only interested in executing the query with no variables and with no context information. Okay, I'm tired. I don't know you, but it's too much Java code, so I would like to see more Groovy code here. So I'm going to show you GQL, which is a DSL over GraphQL and Java. It's still alpha, and I will be publishing it. I don't know why this is doing this, but I will be publishing it during the grids. Yeah, that would be the URL, but it's not published yet. I will tweet it. So how it looks like with Groovy. Okay, so we have the schema, and this is how I would use the DSL. The type film with the field title, and I'm saying that it's a non-null, it's a required field of type string, and the same goes for year, which is a string. I'm adding the description. Well, in GraphQL, it's very easy to add a description, and it's very helpful because it will be published with your schema, and that is very easily to review when your application is up and running. What else? The same goes for the this is the film. Yeah, I'm comparing here the two implementations. I don't know, just to keep in mind. What about the queries? Well, here I'm including both queries. I didn't do it with the Java version because it was too much. So here I'm saying that I have the queries, the last film, which is fetched by the find last film function, and the query by year, which is of this specific type, is fetched by this specific method or function, and it has an argument which is the year. In this case, it's of type string. Okay. Yeah. As I mentioned before, it was too much Java code only for one query, so I couldn't find a space for the rest. What about the execution? Well, in this particular case, GraphQL works the same way. Okay, it has overridden methods, so that if you don't want to add the context or the variables, you can sort the execute method. Okay. So in this particular case, because I'm only interested on having given a schema execute a given query, it's as simple as this. And I get, of course, the same information. The same comparison. I'm not going to enter into that. Okay, that was an example for a very simple queries. What about queries that has arguments? Okay. Let's see an example. This is a query that asks for the a given James Bond film by a given year. Okay, so I'm declaring that I'm going to use a variable of type string for the queries enclose or wrap into that query. Okay, so I will be using that variable there, and I'm interested in the year and the title. How do I pass that variable to the query? Well, As I mentioned, there are several execute methods. This one, you pass the schema, the string, and then a map with the information you want to pass. So anybody knows what is the James Bond film of 1962? Okay, bingo. Dr. No, very good. Now, we have seen simple queries, queries with parameters. Wouldn't it nice just to expose this in an app to the outside world? For that, I may need an application layer protocol, which I'm more comfortable with is HTTP. So I'm going to be showing you some examples. The first one is Ratpack. It's a nice picture, isn't it? Ratpack plus GraphQL, okay? So what technologies I have used for this app? Of course, Ratpack, GraphQL Java, DSL on top of GraphQL Java, and GraphQL. Well, just a few words. One of the greatest things about GraphQL is that the documentation normally is really easy to implement. Normally, I would recommend to use GraphQL in your apps, which is just an index HTML file which attacks your GraphQL endpoint and gives you all the power to interact with the schema and just to be able to discover how your queries work. So that application, so what I need is the schema. This is the full type schema. This is part of the DSL. So I'm declaring all the fields with the different types, the requirements, like non-null and so on. Form type. Yeah, and it fits in the slide. Pretty cool. So what about the queries? Well, we have seen it before. We have the last film and the by year, and we have another query here. Well, we'll see it in a moment. Okay, so that's the schema. So I want to see Ratpack code. So in order to execute the queries, I'm just using the execute method inside a Ratpack handler. By attending Danny's talk, I think I have to change this to a non-blocking operation because execute, by default, GraphQL is blocking. They are working in an asynchronous implementation, but by default is blocking. So I should be enclosing this in a closure and a blocking get. Blah. For the purpose of the example, I'm getting the JSON coming from the front end. I'm wrapping it in a map, passing it the variables and the query. And if I get results like schema validation errors, I will show the errors. Otherwise, I will be showing the data. Okay. Here, I'm just serializing the whole response to JSON. Okay. What about the URL mapping? Well, this is a Ratpack DSL. I'm just exposing the GraphQL engine to the GraphQL DAS context or path. I'm saying that everything that goes here, I need to wrap the JSON into a map, and then execute the GraphQL handler if it's a post request. This part here, I'm exposing the GraphQL console because it's just a static file, pretty simple. I'm exposing it there. GraphQL point, GraphQL web console, and yeah. What about showing you some live coding? Okay. Let me. I have lost my. Oh, yeah. It's another workspace. I was here. Okay, I'm going to show you. I'm running the Ratpack application, and I will be opening really quick, and then demo time. I have lost the cursor. Okay. Yeah. Okay. So I should be showing you. There you go. So this is a GraphQL console, and what it's great for several things. First of all, is this one. If you want to know the schema of your exposed schema, you can you can see it here. So if I had mutations, you will be seeing here mutations, but these are the queries that are exposed by our backend. So I can see that there are 3 different queries. Last film that returns film, by year that receives a parameter and returns a film, and this last one that receives a name and gives a list of films, okay? So you can see here that the description that we can define in the schema are shown through the web console, so it's very handy for somebody that start looking into your schema and to know what the data is about. It's pretty cool. What else? The console is kind of auto-discovery, because you can start saying auto-completion, like saying, I am interested in the, I don't know, last film, okay? So, but I don't know what are the fields. So I have to check to the side. No, I can ask the backend to say, tell me what are the exposed fields. So I can say, okay, the title, and then the year, for example. Okay, if I execute this, I will be getting the information. I can start adding what was the James Bond in that film, Daniel Craig. Okay, so it's really cool, because imagine your front-end developer may be checking, I don't know if I'm going to add this field or not, or I don't know what fields are available. Well, you can check it out with the GraphQL console. What else? For example, another thing that it's worth mentioning. Remember I was saying that a front-end developer may start reducing endpoints just to trying to work out a certain situation. Well, the cool thing about GraphQL is you can group queries. So I can send in a single request different queries. In this case, I'm going to do it. Okay, I'm going to write it the proper way. Year, but I need to define it here. Queries. I'm going to be using a variable called year, which is of type string. Okay. And I'm interested in the title as well, and also the year. Okay. So the only thing it's needed is just to oh, come on. Here is to set the variables, and it's also auto-compilation, because he knows what is the variable you need to set. Okay, so if I execute this in a single request, we are getting data from 2 different queries. So I think it's an improvement. Okay. Let's move on, because I think I'm running out of time. Okay. So our queries and mutation queries are supposed to be able to be batched. and queries are supposed to be computed in parallel. That's also very important. Yeah?
Just the question, is this feature of returning two result sets a feature of graphical or of, is it single HTTP request or is it two requests?
No, the GraphQL engine is supposed to receive that request and to execute in parallel the queries, grab the information and send it back in one single response.
This is not by runtime current, the implementation of runtime you show?
No, it's the GraphQL Java implementation is the one who does that. But mutations are supposed to run sequentially. That is also very important. Whereas queries may not be as important, the sequence, but when you are mutating data, that is important. Okay, that was the wrap example. Oh, sorry. I didn't. Sorry about that. Yeah. To be batch, queries are supposed to be computed in parallel, but mutations are supposed to run sequentially. Okay, Grails plus relay. So relay, I didn't say anything about relay. What is relay? Well, relay is like the best practices of GraphQL implemented in a JavaScript library. Okay, here you have the URL. And it's based on the best practices from GraphQL. And what is this about? Well, things like how to handle pagination or how to handle IDs through the application, or what are the recommended features that you must use from HTTP, and many others. Okay, so it's worth checking that out. But what I want to show you here is a mix from GORM and GraphQL. Okay, there is a plugin out there. It's not published. It's only at GitHub. But it works very nicely, and I think it could be a pretty good base for using GraphQL with Grails. Basically, you can do the same with the DSL I showed you, but moreover, you can use annotation for your domain classes, just to expose those domain classes as a GraphQL schema, and use GORM to retrieve data from those domain classes and expose it to the GraphQL engine. So the only thing I have to do just to expose that is just to annotate the domain class, then add the GraphQL endpoint, and add the relay service to your GraphQL controller. So it's pretty simple. Okay. There are some practices that are important, like hashing IDs or hashing paginations, that are really worth learning. Just to give you a hint about this, is one practice is just never expose the real ID. So they encourage you just to use hashes for the IDs or the pagination logic. So imagine I want to paginate from one page to another. If I expose 1 through 10, I want to expose the next 10. That is a logic that you're implementing. If you want to change that logic and you are exposing the real logic to your developers, then it's harder to change. If you are exposing only a hash that gives you the next page, it's easier to change the implementation. Okay, so I think I'm running out of time. I will be showing you if in the questions time if you are interested in some Grails 3 implementation. But yeah. Well, conclusions. We're ending my presentation. Some conclusions I had from this research. Oh my God, really? Well, I'm going just to say it aloud. Well, It's not that it's not about a REST against. It's not about REST over GraphQL. I think GraphQL should be something more that added to your environment, so that it's easier for your front-end developers just to expose and to exploit your data. Okay. It's a great improvement from the business point of view, and of course your front-end developers mates will love you for that. I hope the talk would help you to improve your applications. And that was all. Thank you very much. If anybody has any question.
One question. You didn't mention any inconvenience or any problems with GraphQL. Is everything peachy? Everything is perfect with GraphQL? Or there is any big problem that you can see with GraphQL?
There are some of them. The most important one is that the first time I faced trying to build a GraphQL application, I started thinking in terms of REST. Things like what happens if some business logic validation fails? I should be returning like 404 or something like that. And it doesn't work like this, because it doesn't have to do with REST. So if you want to use status codes, it's up to you. But you will be messing around with that kind of behavior, because you will be messing terms from REST and terms from GraphQL. GraphQL normally would respond with all the schema validation errors as JSON messages. And if you want to send other type of messages, normally the GraphQL Java and some other implementation, what they do is just to, if you throw a specific type of exception, they will grab your exception and they will convert it to a GraphQL error message, so that you can use the same infrastructure for sending all your error messages. So it's basically up to you, how to use it. What else? Pretty much is the how to deal with everything that is not the queries. For example, authorization. GraphQL doesn't know anything about that. You have to get your HTTP toolkit or framework, add your authentication mechanism, and then use the context from GraphQL in order to see whether you want to give that query to that user or not, depending on the authorization that is given by the underlying protocol. Any other question? Yeah, okay.
Yeah, thanks. GraphQL actually is a bottleneck in front of your microservices. So initial idea of microservices partially was to separate API deployments. So one service can provide its own API, right? And then you can deploy only this service. So nothing like centralized balancer or centralized facade for your API. And GraphQL breaks it. So it introduces an API, a single API, and you can't really split it into multiple ones, because it breaks the semantic of discoverability of GraphQL and relation nature of it. So how do you handle in your practice API changes and API deployments?
Yeah, well, how they tackle this problem is by using fields and type deprecation. So the schema, you mark a given field as a deprecated. So the schema user would know right away if he or should use that field or not. And also the GraphQL engine is able to know which clients are using a deprecated field or not. It's important just to take a decision if they want to wipe it out in the next version or not. So that's different from a REST API point of view, whether you didn't have that much information about which users were using that version or not. About the scalability, I guess I wouldn't attack all the mutation or something that changes the right part of the application, but the reading part, like exposing your data and the clients reading your data, I mean, you can scale load balancing
But I was more talking about the process of deployment. Like with GraphQL, you have to deploy underlying API first, and then some centralized GraphQL proxy, right?
Oh yeah.
And it means that it's a bottleneck inside a big team, like where you have some cross-functional teams with different microservices.
Yeah, I know what you mean. I guess this is not a silver bullet. I guess this has been more a way of having more information and being able to expose or using your data in a more flexible way. But of course, there are problems like scalability that must be solved. I'm not going to give a solution here, but it's especially because of that I was highlighting that GraphQL is not an HTTP new REST API. It's just something that enables you to query your underlying data in a more flexible way. But the way you implement that on top of HTTP in your infrastructure is up to you, and you have to look for the best choices in your infrastructure.
Thanks.
Okay.
Hello. In the same line, is this able to deal with some kind of complexity in your backends? But because apparently all your film information come from the Internet Movie database. But what happens when some of this information you can enable and disable some of the fields, but for a specific backend, or they can be recovered or retrieved from different backends? For example, you have a local database with the films and the years, but the rest of the information is in another provider, and and you want with GraphQL to aggregate all this in a same query. Is that possible, or?
Yeah, of course, but you have to keep in mind that doesn't have to do with GraphQL. GraphQL says this is the data structure that is able to be queried. Then you will point at some specific functions that could be REST APIs, REST clients, some web services from Amazon, things like that, and things like circuit breaking or load balancing or that type of mechanisms. You have to implement it. The only thing that the GraphQL is good at is processing the query, triggering the functions or the services that are responsible for retrieving that data, and that's all. If you receive a null from a given function that has the responsibility for a given field, the front end will receive a null. That's the way it goes. It's up to you just to make sure you have a certain value or you have a fallback for that value.